revision series for CBSE Grade 10 Science. We are going to see chapter 4, which is carbon compounds. Let's start. First of all, we have to understand the first subtopic 4.1, the versatile nature of carbon. Why carbon is so studied in details, and the origin goes back from the modern periodic table. If you see the periodic table, the location of carbon is, first of all, what is the electron configuration of carbon? The atomic number of carbon is 6. That means it has 6 protons and 6 electrons. So that means in the first shell it will have, which is S shell by the way, it will have 2 electrons because it can carry up to maximum 2 electrons only, and the remaining 4 electrons, remember altogether there are 6 electrons, so the first shell will have 2 electrons and the second shell will have, the P shell will have 4 electrons. So the electron configuration of carbon is 2, 4. So in order to reach to the stable octet state, the carbon compound can lose 4 of the electrons, which is kind of difficult, and or at the same time it can gain 4 electrons. Both things are theoretically possible, but not practically quite observed very well. Instead, it does something extraordinary. Instead of forming an ionic bond, which is typically formed by gaining or losing electrons, instead carbon forms covalent bond, which is nothing but sharing its one of the electron with 1 electron of somebody else. Mostly it's hydrogen. We are going to study that in detail. So instead of ionic bond, which is gaining or losing electron, carbon will follow, it will form covalent bond, which is nothing but sharing of 2 electrons. And a typical structure is like this one. So that means, remember, carbon has 4 electrons in the outermost shell. So if it shares 4 electrons with 4 more electrons, it will achieve the stable octet state. So the typical partner in this configuration will be hydrogen. Hydrogen has only 1 electron, so it will share with the outermost shell of the carbon, and in such cases we need 4 electrons. So carbon can form 4 covalent bonds, let's say 1 each with hydrogen atom. So this is the simplest saturated hydrocarbon, which is CH4, methane, and in 3 dimension it looks like a tetrahedral structure, but when we write that on a piece of paper, we write it simply carbon at the center and then 4 atoms at the 4 vertices of square, let's say. Now each line which is shown here is nothing but a single covalent bond, and 1 covalent bond is nothing but 2 electrons, 1 from carbon and 1 from the partnering element. In this case it is hydrogen. So if they say write the simplest structure of methane, which is CH4 by the way, you have to write something like this. If they ask you electron structure, remember 1 line which is 1 covalent bond, which is nothing but 2 electrons. So instead of that we can simply show something like this one. Here 1 dot represents 1 electron. Since 1 covalent bond is 2 electrons, so 4 covalent bonds will be 8 such electrons, and that will be the electron dot structure of methane. We can write similar dot structures. They will be slightly getting more and more complicated as number of atoms, carbon atoms increase. Before that we have to see what kind of nomenclature we follow for hydrocarbons. When they say hydrocarbons, as the name suggests, it is molecules of hydrogen and carbon. Now let's say a typical hydrocarbon falls normally in one of these 3 categories, and the sequence is alkane, alkene and alkyne. Again I repeat this sequence: alkane, alkene and alkyne. It depends upon how many number of single or double or triple bonds it has, but the sequence will be always like this one. Alkane is saturated and alkane, alkyne are unsaturated. Let's see what does that mean. The typical structure of alkane, which is fully saturated, everything is single bond. There are no double or triple bonds between carbon atoms. So if that happens, then that homologous series, that particular sequence is referred as alkane, and N is the number of carbon atoms. Number of hydrogen atoms will be always given by this formula, twice of number of carbon atoms, 2N, and plus 2. We will see that why that plus 2 comes here, but in case of alkene, because of one double bond reduces the number of hydrogen atoms by 2, and it will be CnH twice of N. In case of alkyne, there will be one triple bond, so number of hydrogen atoms further reduces by 2, and the final formula will come out to be CnH2n minus 2. Here C represents number of carbon atoms, H represents number of hydrogen atoms, and N is the actual quantity, numerical value of the carbon atoms. So what are the characteristics of these things? Alkane, everything is single bond. There is no question of double or triple bonds. In alkene, there will be one double bond, and alkyne will be one triple bond. So always remember the sequence: alkane, alkene, and alkyne. Remember, these are generic names. Now we are going to see particular names when carbon atoms increase from 1 to let's say 6 or 7. So let's start with 1. If you have 1 carbon atoms, then this will be referred as methane. So this will be C1. Well, 1 if you write or don't write, it doesn't matter. Hydrogen atoms will be twice of 1 plus 2. So it will be 4. So CH4 will be the chemical structure of methane. Now, in case of alkene and alkyne, this is not possible, because in order to form a double or triple bond, you need at least minimum 2 carbon atoms, and that's why the first member will be missing in case of alkane and alkyne, the alkene and alkyne. In case of 2 carbon atoms, the nomenclature will be ethane, ethene, and ethyne. So if you want to find out what is the chemical structure of ethane, so the number of carbon atoms is 2, so it will be C2H twice of 2 plus 2, that will be 6. So C2H6 will be ethane, C2H4 will be ethene, and C2H2 will be ethyne. We can keep going: propane, propene, propyne, butane, butene, butine, pentane, pentene, pentyne, and then hexane, hexene, and hexine. In your textbook, standard NCERT textbook, they have stopped at number 6, but you can actually keep going: heptane, heptene, heptyne, octane, octene, octine, nonane, and so on. So let's restrict ourselves to only 6, but the general structure is alkane, alkene, and alkyne. And let's see what does that mean. Say, for example, if I want to get the structure or chemical formula of pentene, remember, pentene, first of all, pent means like there will be 5 carbon atoms, and ene means it belongs to alkene category, so it's the middle category. So the generic formula will be CnH2n. So if N is 5, because it's pentene, then 2N will be 10, so that will be C5H10. So the chemical formula for pentene, being a member of alkene group and coming from a family of 5 carbon atoms, the formula will be C5H10. Let's repeat that for hexane. Hexane belongs to alkane homologous series. It will be CnH twice N plus 2. Since it is hex, so it will be 6 carbon atoms. So twice of 6 is 12, plus 2 will be 14. So the formula for hexane will be C6H14. Once you get a feel of this one, there is nothing complicated. If you know the sequence, alkane, alkene, alkyne, and if you know methane, ethane, then propane, butane, pentane, hexane, so these you can actually create chemical formula and the name of any member of this homologous series. As I said, in general, alkane are saturated hydrocarbons because they are all single bonds. They are fully saturated, as opposed to that the 2 homologous series on the right, because they have double and triple bonds, they will be collectively referred as unsaturated hydrocarbon. So having said that, let's go to the next subtopic, which is how we can have derived compound names. So let's say we have defined ourselves for alkane, alkene, and alkyne. Now we are talking about generate compounds which are either let's say halogen compounds or alcohol compounds, aldehyde compounds, and so on. So there are certain groups, and on this slide I have mentioned 3. On the next slide I am going to again mention 2. These are taken from the NCERT standard textbook. You can refer that one also if you want. The first group is haloalkane. Now here halo stands for halogen. If you have if you have recalled the periodic table of elements, halogen refers to the group which is just before noble atoms, which is one before the last group, and that would be chlorine, fluorine, chlorine, bromine, iodine. So these will be your halogen. Collectively they are referred as halogen atoms, and they will be always denoted by prefix and not by suffix. So here I have put dash because haloalkanes are characterized by prefix name, whereas the other things are characterized by suffix name. So I have put dash here. So either it will be prefix or suffix, it will never be both. So for halogen atoms it is prefix, for remaining it is suffix. Now let us take an example. I am going to take one reference alkane, which is, let's talk about propane. Propane comes from saturated hydrocarbon. It's from alkane homologous series. So propane is the third member. So it will be C3H 2 times 3 plus 2, that will be 8. So it will be C3H8. I have shown the generic structure of propane. This will be our reference. Now every time we are going to replace one of the hydrogen atom. Remember, everything is saturated. There is no question of double or triple bonds here because it's a saturated hydrocarbon. And every time we are going to replace one hydrogen atom with one of these characteristics, and suddenly it becomes a member of one of these groups. So let's start with halogen or haloalkanes. So it can be either fluorine, it can be either chlorine, bromine, or iodine. So let's assume that it's chlorine. Let's replace one of the hydrogen atoms with chlorine. Everything else is identical. So it is still propane, but one of the hydrogen atoms is replaced by chlorine. So now it belongs to haloalkane group. Let's see how we can name it one. Since it is haloalkane group, it will be denoted by prefix and not by suffix. And since it is chloro, so the name of this one will be chloropropane, because the reference, the base from which, the base compound from which it is derived, it's propane, and only one hydrogen atom is replaced by halogen member, specifically chlorine, and chlorine halogen members are denoted by prefix, not by suffix. So it will be chloropropane, and that will be the name of the component. Let's go one step further. What is if it is an alcohol? If it is alcohol, there is no prefix, but the suffix is OL, indicating it is an alcohol. Let's repeat the same exercise. Alcohol is actually OH group, which is hydroxyl group. Let us again start with propane. Let's assume that one of the hydrogen atoms is replaced by OH group, making it as a alcohol. So in that case, the chemical structure, the chemical formula will become like this one. And again, the base compound is propane. Now it has become alcohol. For alcohol, the prefix is nothing, suffix is OL. So it will be propanol. Instead of propane, it is propane alcohol, or in short, propanol. Let's go to the next group, aldehyde. Aldehyde is no prefix, suffix is al, Al, to indicate it is aldehyde, and it is characterized by the carbonyl group, which is CHO, and the base reference material is still propane, and it will be now propane aldehyde, or in short, propanol. So the name of this compound, because of this HC and double bond O. Why there is a double bond O? Because hydrogen requires only one atom to be shared, one electron to be shared. On the other hand, oxygen requires two, because its chemical electron configuration is requires 2 electrons to complete the stable octet state. So oxygen will be always associated with a double bond by default, whether it is saturated, unsaturated, that has got nothing to do with oxygen. Oxygen is always associated with double bond. Hydrogen is always associated with single bond. And carbon, well, there are multiple possibilities. You can have single bond, double bond, or triple bond. So in this case, it will be aldehyde of propane, and it will be propanol, Al, that will be the suffix. Let's take this one step further. Let's see the next group, which is ketone. ketone, you don't have any prefix, but the suffix is ONE, like on, that represents the ketone group. Let's again repeat the same exercise. Let's start with propane. The base material is propane, and now what is the characteristics of the middle two hydrogen atoms? The middle two hydrogen atoms are replaced by a single double bond, a single oxygen atom with having a double bond. So the structure will be something like this. In the middle you have C double bond O, and that is the typical characteristics of ketone. Here the base reference material is propane. It's the ketone of propane, so it will be having no prefix, but the suffix will be ONE. So since we started with propane, the name of this material will be propanone. Let's go one step further. Carboxylic acid. Carboxylic acid, the prefix is nothing. The suffix is oic acid, indicating that it's carboxylic acid. Let's repeat the same exercise. We start from propane, and now the defining structure is C double bond O and then OH. That COOH is typical characteristics of carboxylic acid, and it is a carboxylic acid of propane, so this is propanoic acid. So this is how we can create the name of derived components when a particular alkane, one of the hydrogen atoms is replaced by alcohol, aldehyde, ketone, carboxylic acid, or simply halogen atoms. So I hope you have understood this one. Let's see whether you have got this correct. This is one of the questions from previous exam papers. The name and formula of the third member of the homologous series, alkyne. The keyword here is alkyne. Remember the sequence: alkane, alkene, alkyne. The alkyne is the last column, the last triple unsaturated, highly unsaturated with the triple bond. That's the series, homologous series we are talking about. Now this is a tricky question. They have asked third member. So you will be tempted to take a number of carbon atoms as 3, but let's revisit the table which I was talking about. Again, the sequence is like alkane, alkene, alkyne, and remember, in the first time only alkane is possible, but since double bond and triple bond require at least 2 carbon atoms, so the first member is missing with single carbon atoms in case of alkene and alkyne, because in order to become unsaturated, they need to have at least 1 double bond or at least 1 triple bond, and for that purpose they need minimum 2 carbon atoms. So that first member is not possible, and because of that, now if you complete this series, the third member is actually not with the 3 carbon atoms, it's actually with the 4 carbon atoms in case of unsaturated. This part you have to be a little bit careful about, and the third member of the alkyne series will be actually butane with the carbon atoms equal to 4. The generic formula is CnH2n-2, so that I will write it separately. Here n becomes 4, so 2n-2 will be twice of 4 minus 2, that will be C4 and H6, so that will be the chemical formula. So the name of the third member of the homologous series alkyne, that will be butane with the chemical formula C4H6, and that will be option D. That's all for the time being. Hopefully you have learned something. We will try to bring as much knowledge and as many such videos as possible. Please keep visiting our YouTube channel, and please also visit our website vidyanti.com in order to get the homework solutions and AI generated notes. This is Prashant sir recording live for vidyanti.com. If you like this video, please share and subscribe if you haven't done so. Thank you very much. Hopefully we will meet again. All the best.